So today we're going to talk about breadboard ends, and I want to show you 4 different ways to make them. Now the thing with breadboard ends is they're kind of simple in concept. You have a board that goes against the grain at the end of a panel like this, and it can help keep the panel flat over time, but one of the key elements to a breadboard end is it has to allow that panel to expand and contract. If it doesn't, it fails. And unfortunately, there's a lot of bad information out there about breadboard ends. I saw a YouTube video where they just put pocket screws across the...
No!
Well, I was told that wood movement actually isn't right.
No!
But if my panel is made properly, then I don't think I really need breadboards.
That's actually true.
Now that's actually one of the big misconceptions about breadboards is that you have to use them. If you have a big tabletop, the truth is you don't have to use a breadboard, but you can add one if you want that extra insurance policy. If the wood is milled properly, we've got a video on making good flat panels, you're gonna have no problems. Most of the time that panel will stay fairly flat, but if you want that extra insurance policy, a breadboard is nice if you don't mind the way that it looks, because it definitely makes a visual statement. Now there are a lot of different ways, even amongst the ways I'm going to show you, there are variations that you could do to make it a little bit different, but as long as the breadboard attaches securely, is held to the panel, and allows that panel to move back and forth, it's doing its job. All right, so here are 4 different ways, starting with the most, what I would consider traditional version. Now this is the haunched tenon version of a breadboard, the classic way to do it, and bear with me for a minute because there's a lot going on here. So first things first, we need to allow for movement. So you can see we have the haunched tenons here, that just means you have this long tenon body and then it drops down to this sort of smaller tenon or tongue that goes all the way across. So when this guy is in place, we have to allow for movement, and the way you do that is by gluing it in the center only. That stabilizes this area, and then you let the rest of the panel expand and contract as it wants to. So we can't use glue here or here, right? So you might be tempted to just glue it in the middle, pop that thing on there and call it done. But the problem is, over time, you will get gaps on the outside because there's nothing holding these two together, right? Wood is gonna move and you'll probably see an unsightly gap there. So how do we hold the ends of the breadboard in? We're gonna use a dowel, all right? And it's gonna be a specially drilled hole that allows this dowel to literally pull that breadboard into the panel. And that's done with a draw bore, is what we would call that. As this dowel goes through here, it's gonna weave around a slight offset and then come back the hole on the bottom, and that's gonna hold it in. It's gonna be like a built-in clamp. It's pretty cool. The other thing you might notice is that each of the mortises is a little bit bigger than the outside tenons, right? The middle one can be exact size, but we have to be oversized here. And then the groove for this tongue, you can see that groove allows for a little bit of movement there, right? So as long as we allow for movement across this whole length here and everything is free to move and isn't locked down, this should be reliable. And another thing you'll notice, and this is just kind of something I like to do that I learned from sort of the green and green style, is to leave the breadboard a little bit proud of the outside. The reason is because if you start out with these nice and flush, no matter what, over the course of time, it is either going to shrink and be below the breadboard, or it's going to expand and be above the breadboard. So I would rather intentionally design a little offset there so that this top panel can kind of expand and contract, and the breadboard is always slightly proud as a decorative feature. Now, you don't have to do that, you can go flush, but I do prefer to keep mine just a little bit oversized, and I think it just makes the breadboard look better over the course of time. Now, let me show you exactly how to make the haunched tenon breadboard. So the first step is to lay out the mortises in the breadboard. The breadboard is about 20 inches long. The outer mortises are located in 1 inch in from the edge, and they're 2.5 inches long. The center mortise is also 2.5 inches long. The 1/4 inch mortise is centered on the workpiece, so I'll draw a couple of lines that'll help set up the bit. With a 1/4 inch upcut spiral bit in the router, I'll adjust the edge guide so that the bit is perfectly centered between the 2 lines. Now I can plow out the mortises. To help balance the router, I actually clamp my 2 breadboards together. It gives me a lot more support. The mortise depth is 1.5 inches. So how do you decide how deep to make the mortise? Well, it's a good idea to go at least halfway into the breadboard width. 2/3 of the way would be even better. This breadboard is 2.5 inches wide, and I'm making the mortises 1.5 inches deep. Keep in mind, the depth is often limited by the tool that you're using to make the mortise. Next, I'll mark in a 1/2 inch in from the edge to denote the shallow groove location. The groove is then routed from end to end at a 1/2 inch deep. Obviously, you'll want to repeat this process on the other breadboard too. So now we can focus on the panel with the haunched tenons. First step is to make a long tenon that goes all the way across the panel. Using the dado stack and a sacrificial fence, I can remove a little bit of material from each face, sneaking up on the perfect fit. Once there, I'll move the fence to the final position, making the tenon just shy of 1.5 inches so that the tenon doesn't completely bottom out in the mortise. With that setting locked in, we can also cut the tenon on the other end of the panel. To mark out the long tenon locations, we'll use the breadboard itself. I simply transfer the start and stop points for the mortises and the groove to the tenon. From there, we need to reduce the size of the outer tenons and the small tongue to allow for movement. I take away about 1/8 of an inch on each side of each tenon. My drawing is a little bit goofy here because I forgot to remove some extra stock from that small tongue, and you'll see the fix for that later on. Keep in mind that the bigger the panel and the higher the potential humidity swings, the more room you're going to need to allow for expansion and contraction. The center tenon, by the way, is cut to the same size as the mortise for a nice snug fit. And just for convenience, I'll use a 1/2 inch brass block to lay out the remaining tongue areas. Now we could certainly come up with a safe way to do this with power tools, but I just find it easier and more fun to whip out the handsaw. And none of these cuts really need to be super precise, so if you're new to handsawing, this is a great low-stakes way to get some practice. To remove the area between the tenons, I'll use a coping saw. Coping saws are great because you can make nice tight turns and it's a fairly thin kerf, so it's good for removing stock between tenons and dovetails. Now on these final end shoulder cuts, we do want to be careful. The breadboard will need to sit nice and flush against this end grain surface. To finesse the tongue, I'll file it flat and chisel where needed. You want this short stubby tenon to be just shy of that 1/2 inch groove in the breadboard. The end shoulder then gets flushed up with a chisel. And here's where I correct my mistake of not removing extra material on a tongue. A pretty simple adjustment with a saw and a chisel. Because the mortises and grooves were made with a router, the ends are rounded. So I'll round over the tenons and tongues to roughly match. Now for the first test fit. Since the joinery is essentially cut short, there really shouldn't be too much of an issue with this fit. If there is an issue, try to identify the source and remove stock as needed. Next up, we'll work on the drawbores. It starts by laying out the 1/4 inch holes roughly at the center of each tenon. The holes are then drilled all the way through the breadboard. With the breadboard back in place on the panel, we can transfer the hole locations using the same brad point bit. A little tap is all it takes. Using a pencil, I can darken the puncture so that I can see what we're dealing with. Now the goal here is to drill through the tenons but slightly push toward the panel. The offset would be about 1/16 of an inch, but that's just enough to help pull the breadboard into the panel when a dowel is driven through all the holes. The center tenon gets a single standard hole. The outer tenons get a couple of holes that essentially create a 1/2 inch long slot. Using a chisel and a rasp, I can remove the material between the holes. The goal is to allow the dowel to move from side to side, but not from front to back. With the breadboard back in place, you can see how the holes are just slightly offset. For the final attachment, I'll add glue to the center tenon and tongue. As long as it's not more than, say, 4 to 5 inches of area, we should be okay regarding movement. The breadboard is then clamped in place. Using a knife, I taper the end of a 1/4-inch dowel to make it easier to take the bend. I actually like to make my own dowels using a dowel plate, but you could certainly use commercial dowels to save time. The center dowel can be glued in place completely. I hammer through until the dowel protrudes from the bottom. For the outer dowels, the process is a little bit trickier. I start by putting glue in the hole on the underside. The glue should only contact the breadboard, not the tenon, so don't go too deep. From above, the dowel is hammered in just until it pokes through the bottom. Next, I'll add glue to the dowel on the top side and hammer it in just about a 1/4-inch more. This technique results in the dowel being glued to the breadboard above and below the tenon, but not being glued to the tenon itself. This allows the tenon to move as needed during fluctuations in humidity. After the glue dries, I use a flush trim saw to cut the protruding dowels. Then a little sanding to flush everything up. Of course, on an actual tabletop, you'll want to round over your edges to taste, and some of that stuff is just easier to do before you attach the breadboard. So now let's do a simpler version. This is the wide tenon version. If you look closely, you'll notice that it's really the same as the haunched tenon version, except for we just don't have the haunches. There's no cutouts with that small tongue all the way across. What this means is that the groove that goes all the way through our breadboard is now continuous at that full depth. So, the disadvantage being that this is now a little bit flexible, right? Because we have so much material removed, we've actually taken a little bit of integrity away from the breadboard. So that may not be the end of the world, especially on a smaller top like this one, but it's absolutely something to be aware of and to think about if that's what you want in the final piece. But it is a lot easier to make, right? So let's get to it. The breadboard layout is much simpler now, so I just mark in a 1/2 inch in from each end and set the router up for a centered groove. Again, clamping both pieces together provides much needed support. Now this is a very deep groove, so it will take several passes. The tenon on the panel is then cut just shy of 1.5 inches all the way across the board. Now we can lay out for the shoulder cuts on the ends, removing about 3/4 of an inch of material. The shoulder is then flushed up with a chisel. And because the groove in the breadboard is rounded, we can round the tenon to match. Though in this case, there's enough room for expansion, so it probably won't ever matter. Now we can lay out and drill the holes in the breadboard. The breadboard hole locations are transferred to the tenon and then offset toward the panel shoulder by about 1/16 of an inch. The center hole is just a single hole. The outer holes are drilled twice to make a 1/2 inch long slot. The area between the holes is then cleaned up to allow for a future 1/4 inch dowel to move from side to side. And once again, you can see the drawbar offset holes that will pull the breadboard tightly to the panel. The assembly is the same as the haunch tenon version, with glue in the center and the careful dowel gluing technique on the outside dowels. What's different here is that we have to be careful to make sure the breadboard doesn't bow out after driving the dowels. With all the material removed in that groove, there's enough flexibility there to cause some issues, so it's a good idea to use a clamp to flatten it out. Once the glue is dry, the dowels can be trimmed and sanded. And what's cool is the other end of this panel has the haunched tenon breadboard on it, but from the outside both look exactly the same. And that's good since I actually plan to use this as a top for a future project. All right, so next up, we've got the screw version of a breadboard. This is actually inspired by a lot of green and green breadboards that I've seen over the years. It's a fairly simple construction where you have a small 1/2 inch tongue. We have spacers for a screw. And then, of course, we have the 1/2 inch groove all the way through the breadboard. And certainly, as usual, we got movement on both sides here. So the way that this works, so you pop this guy on here like that. Now, instead of drawbars holding this thing together, we're going to use screws. So you see the holes out there? These are counterboard. We can cover those when we're done, but we have glue and one single screw in the middle with no room to move. And on the outsides, we're going to have screws with no glue. The screw, of course, is going to pull that nice and tight. And the screw hole is kind of reamed at a bit of an angle. right? And that angle allows this screw, here, let me drop this in there. It's gonna allow that screw to move. So it will move with the expansion and contraction of the panel. And this space here is what allows that to happen, right? So let's make the screw version. I'll start by marking in a 1/2 inch from each end of the breadboard. We'll set up for a 1/4 inch groove that's only a 1/2 inch deep. Next, we'll lay out the screw locations on the outside edge of the board. Each location will be pre-drilled with a deep countersink. The screws need to move freely, so I'll use a larger bit to continue drilling through each hole. On the outer holes, I'll ream them slightly by angling the drill and then just drilling back and forth. The holes will then turn into slots, which will allow the screw to move. We want about 1/8 of an inch to a 1/4 inch of movement. For the panel, we'll use the dado stack at the table saw to make a tongue that's just a hair under a 1/2 inch long. If you have trouble getting a good fit, you can always use hand tools to finesse the tenon to perfection. That goes for any of these breadboards. Using the breadboard itself to transfer the screw locations, I'll cut out about a 1/2 inch of space for each screw using a fret saw. At each end, I trim the tenon and flush it up. Of course, the tenon is trimmed a little bit extra to allow for movement in the groove. With the breadboard back in place, I mark the screw center points and transfer them to the end. Now we'll pre-drill the holes for the screws. If we don't do this, the screw can split the panel when we drive the screw home. And by the way, while we wanted a loose fit in the breadboard, the panel screw hole needs to be small enough to allow the screw to have something to bite into. To attach the breadboard, we'll glue the center 4 inches and pop the breadboard onto the tenon. The center screw is driven first, followed by the outer screws. To cover the screw holes, we'll cut some tapered plugs. Now if you want to hide these, use the same species. If you want an accent, just use some dowel stock or whatever species you like. In this case, I'm trying to disguise the plug, and if I align the grain, you'll notice that they actually pretty much disappear after sanding. Now with finish, they'll be a little bit more obvious, but most people will never notice them. Now, every time I bring up breadboards, there's at least one person who asks me, can I do this with the domino? And the short answer is yes, but you really do want to use the largest dominoes you can. If you look at the width of these, when you create slots that allow your dowel to move, you don't really have a whole lot of room to play with here. So you gotta be very careful. And I do think this works best with the bigger size dominoes, right? So you can only go so small. But you do have to be very careful about which slots get the small slot, which ones get a wider setting, and you have to make sure that these dominoes kind of become part of the panel. Of course, dominoes are loose, so if it's loose in both pieces, it's kind of game over. So you can see these are already glued in, and you'll see how we do all of this. So let's get to it. First thing I do is lay out the domino center points. The spacing isn't super critical, but on a panel of this size, I want 5 of them laid out symmetrically. Those marks are then transferred from the panel to the breadboard. We'll be using 12 by 50 millimeter dominoes. On the panel side, the slots are cut using the tightest setting. The dominoes are then glued into the mortises. By the way, you can get more mileage out of this process if you make your own dominoes and make them wider. Everything's just better and easier if the tenons are wider than these 50 millimeter pre-made dominoes. On the breadboard, the center domino is just using the same tight setting that we used on the panel. The remaining mortises are cut on the next wider setting, and this is how we allow for expansion and contraction. For the drawbore holes, we'll drill a 1/2 inch in on each domino center line. and this is a 1/4 inch hole. With the breadboard in place, we can prepare for the drawbore by transferring the hole locations to the tenons using the 1/4 inch brad point bit. Once again, we're going for the 1/16 inch offset toward the panel shoulder. The center domino gets a single hole, and the outer dominoes get 2 holes that help create a slot. The domino surface is textured and the dominoes aren't very wide. This is why I said you'll have an easier time if you make your own dominoes that are wider. But I want to show you that it is possible using pre-made dominoes to do breadboards. To attach the breadboard, we'll add glue to the center domino and about 2 inches to either side. The center dowel can be completely glued in place. The outer dowels get the same careful gluing treatment we've used so far, making sure that we only glue the dowel to the breadboard and not to the tenon. Now, just a couple of things you might need to know here. First of all, if you do what I do and have these overhangs, you're going to want to soften them a little bit. So add a little chamfer or a little round over where the side meets the end of the breadboard, and that's just going to make it look better, it's going to feel better, and it's going to look very purposeful at that point. The other thing has to do with hiding your dowels. So if you want to do the drawbore, but you don't necessarily want to see those end grain dowel pieces all the way across, you've got options. First of all, I used walnut because I wanted it to be an accent, but I could have used cherry here, and the cherry would have blended in a little bit better. Still, it's end grain, so it would have been darker, and I would notice them. If I really, really didn't want to see anything from the top, here's what you do. You just drill from the underside. And when you're making your, actually drilling your holes into the breadboard, don't go all the way through, right? Just go to the point where it just punches through that second skin, the other side of that breadboard, and then stop. And then you could just apply your dowels from the bottom up, punch them through as far as they go, and stop when it hits bottom. You do have to be careful here, though, because if the material's really thin, that skin isn't really very deep, so the dowel isn't necessarily going to have very far to go. So frankly, I only like that method if you're working with a thicker top material. 3/4 inch is going to be a little bit tricky, but if you go up to 5/4 stock, 6/4, 8/4, all those will probably work just fine with that technique. All right, so there you go, 4 different ways to make breadboards. All of them are perfectly viable. I mean, which one you should choose is going to be up to you, depending on the tooling that you've got, the time investment you want to put into something like this. I would say, hands down, the best version here is the traditional haunched tenon version, but it's also the most difficult to make. The other thing you might want to keep in mind when you make these sorts of breadboards is the size of the piece you're working with. So if you go any bigger than this, it becomes a little bit difficult to use a router, right? I went about 1.5 inches with mine, and that's kind of maxing out the depth that I can go. So if I need to go deeper, which is what you would normally need to do if you go with a larger, let's say, farmhouse style table, you need to go pretty darn deep. Well, you can't do that with a router, right? So you would really have to go to something like a hollow chisel mortiser. And if you do a lot of this, that would be a good investment for you. Or you just use a drill and a chisel and you go as deep as you need to. That sounds terrible, but if that's what you want to do, that's definitely something you can consider. So the size and scope of the project will also impact which one of these methods you choose and if you go with breadboards at all, because again, just to reiterate, they're not always necessary, all right? So thank you for watching, everybody. I hope you jump into the world of breadboard and building because it's cool, it looks good, but it may not be right for every project, right? Thanks for watching. Do you want to do a practice run?
Just do it.
I saw a YouTube video where they just put pocket screws across the whole thing and everything was fine.
No.
I'm not sure how I expected that to go, but that wasn't quite it. I saw a YouTube video where they just put
No.
Oh, Jesus. I have a headache now.
You want me to hit you? I'll hit you.
Okay, I think we got it, Nicole.
All right.
Hey, thanks for your help.
Bye.
Hey, bring back a Tylenol, would you?